We are HxMx, and this is our engineering showcase video for our project MALP.
I'm Kinsey Sidness, I'm the project manager.
I'm Dustin Tish, I'm the hardware engineer.
Jeremy Brand, the software engineer.
I'm Shane Blows, the system integration engineer.
Our stakeholders are Dr. Joseph Morgan, our technical advisor, and Mr. Matt Leonard with T-Star as our sponsor.
This is MALP. MALP is the Mobile Analytic Laboratory Platform. MALP was built 15 years ago by NASA and is needing to be refurbished with updated technologies. NASA has given this project to T-Star, who has given this project to multiple capstone teams. This project is unique as it is a multi-team approach. Here is our system architecture to ensure that all teams stay within their subsystems. Our team, HxMx, is creating a simple vision subsystem, the power subsystem, and the control subsystem. Another capstone team, Interstellar Communications, is creating the base station and the communications subsystem. A student organization, Sumtech, is creating a terrain mapping subsystem. A capstone team, Reach, is creating a sample collection subsystem. This project will also have additional subsystems built in the future, such as autonomy and collision avoidance. Here is our problem statement. T-Star needs a mobile robotic trainer capable of emulating realistic control scenarios to further support NASA. NASA has the six-wheeled rover, MALP, that needs to be refurbished and implemented with new technologies. Therefore, NASA requires that the MALP be restored to functional operation with the ability to integrate additional modules and capabilities in the future. Here is our conceptual block diagram. MALP was given to us with two motors, the motor drivers, and the wheels. MALP is chain-driven. We then supplied the batteries that will power the queso board. The queso board then sends power and motor signals to the motor drivers. The motor drivers then send PWM signals to the motors. There are 4 emergency stop buttons on the body of MALP, along with 4 lights. The queso board powers the lights and the 2 cameras. The queso board also powers the Raspberry Pi. On the Pi is a 9-axis accelerometer, gyroscope, and magnetometer. The Pi is connected to the local controller. This local controller allows HxMx to demonstrate its capabilities. The Pi, the queso board, and the cameras talk over Ethernet to the Interstellar Communications switch, which then relays information to the base station. Here is a picture of MALP prior to us taking out all the electronics and surveying them for use within our own project. These electronics were mostly outdated and not useful for the project. This picture shows the wiring of the motors when we were first given the rover. Again, many of these cables were not necessary to keep. Here we have the updated version of the rover. These electronics will be explained further along in this video. Here is a picture of the updated motors. We were luckily able to use the original motors that were given to us by NASA after changing out the oil. Here's a closer look at the electronics on board MALP. This enclosure holds the queso board, a Raspberry Pi, and a Launchpad debugger board. The queso board is the PCB that was designed by HxMx. The board regulates voltages to power other components on MALP, such as the Raspberry Pi, the lights, and the camera that is on board. The board also monitors the voltages throughout the system. For our project, we have an Xbox controller plugged into our Raspberry Pi. The Pi reads the inputs of the controller and sends these readings to the queso board, and the queso board then sends PWM signals to the motors. As I said before, the queso board is used to regulate voltages down. It is capable of regulating voltages to 12 volts, 5 volts, and 3.3 volts. In this video, it will show our initial testing on the alpha board. This first clip shows it regulating down to 5 volts. This second clip shows it regulating down to 12 volts. The final clip shows it regulating down to 3.3 volts. As you can see, all of the voltages were stable, which allowed us the ability to power different devices using this board. One of the necessary capabilities we had to implement was power monitoring. The MALP rover is powered by 2 12-volt batteries. The queso board will be monitoring these voltages, and these voltages will be displayed on the GUI built by Interstellar Communications. Here we are testing the 12-volt INA. As the voltages change, it is reflected in the Pi's console. As you can see in this video, there are 4 lights around the body of mount. The first step of ensuring the operation of mount is by hitting the Y button on the Xbox controller. This turns on the lights and is a safe way of determining everything is hooked up and communicating properly before moving the rover.
Left reverse. Right turn. Left turn.
This video shows how the motors move with the local controller. As Dustin moves the joysticks forward, the respective wheels move forward. As he moves them backwards, the respective wheels move backwards.
Right turn.
For safety measures, HxMx had to implement 3 different types of emergency stops. The first e-stop demonstrated in this video is the controller e-stop. When an operator hits the B button on the controller, the motors stop. The motors will not move again until the start button is hit on the controller to clear out the emergency stop. Please note, in this video, the first time the button is touched, it was not completely depressed, so the motors did not stop. The second e-stop is using the red emergency stop buttons. There are 4 buttons on each corner of mount. When this button is pressed, the motors will stop and won't move again until the button is pulled back out and the start button is hit on the controller. The final e-stop is loss of communication. In this video, it will be demonstrated by unplugging the controller. Through the software we have built, the rover will stop moving once this loss of communication is detected. We apologize for the quality of this video, as it is a hard video to shoot with only a single person.
We're going to do a left turn.
This final video demonstrates our professor driving mount, turning it, driving it backwards, and using the emergency stops.
We're going to screw it up. We're going to go forward. I'm going to push the e-stop button on the controller. We've stopped. I'm going to push start on the controller. I'm going to go forward. And we're going to go backwards. And we're going to do a right turn and a left turn.
Thank you for taking your time to watch our video. If you have any questions, please feel free to contact the team at the email listed or check out our website hexmex.weebly.com.